All right, and we are live. Good morning, everyone. Thank you for joining us today for another great workshop through Alchemy University. Today we have Sunny from Superfluid. How are you doing, Sunny?
Doing great. Really glad to be here.
Amazing. Oh, let me mute the YouTube side. I have that going in my ear. Great. Yeah. So today, Sunny's going to be walking us through a workshop that is an NFT that grows as you order it. Sunny, I'll basically leave the floor to you, but do you want to give a bit of a background of who you are, what Superfluid does before we jump into the workshop?
Sweet. Yeah, I'll put the what Superfluid is part as part of the workshop, so we can dive into that right after. But yeah, to introduce myself, I'm Sunny from Superfluid's developer relations team. My job is to make the experience of building on top of Superfluid as good as possible. Really pumped to be here with Alchemy University. You guys have been doing such great stuff for the Web3 space and onboarding developers. So happy to be contributing today with this workshop. And yeah, we've got a really cool topic, so would love to share my screen and dive right in.
Amazing. Great. Well, yeah, go for it. And like I said, I'll jump in if anything comes up, and we'll open up for questions later on today. I will be sharing some of the source materials that Sunny will be going through in the chat, so you guys can go through it together. But yeah, feel
Sweet.
free to share your screen, and I'll give it all to you.
Awesome. So today we're going to be making an NFT smart contract that evolves as you stream it money with Superfluid. So today we're going to be basically doing a lot of Solidity. So I'm expecting that you guys are coming with more than beginner experience. You've used ERC20s, you've written smart contracts with them. Same with ERC 721s. I'm expecting that you've done some development with the hard hat framework and you have some JavaScript experience. So if you check all these boxes, you're going to have a good time following along today. So let's start off by breaking down what Superfluid is. Superfluid, first and foremost, is an EVM smart contract framework. We're deployed on all the major EVM chains, and we allow you to do something called money streaming. That is the continuous per second payment between accounts of what we call super tokens. And you're able to stream tokens between accounts in these per second streams or flows instead of in discrete lump sums. So you can imagine, let's say I'm paying someone a salary, instead of paying them with discrete lump sums at the end of each month, say pay them that 5,000 USDC at the end of each month, I can stream them little bits of USDC per second and not have to do those kind of like repetitive lump sum payments. And so this is really good for those kinds of fixed rate, continuous fixed rate payment use cases. So because Superfluid is an EVM smart contract framework, and we're dealing with smart contracts here, the payments that money streams provide, they're done with no delays, no payment risk, and no intermediaries, because this is a blockchain and we have instant settlement, which we love. All right, so that's what Superfluid is in a nutshell. Let's talk a little bit more about how the Superfluid protocol is structured. So the protocol is focused around the super token, which is basically an extension of the ERC20 standard with more balanced movement functionality. So basically, you have your ERC20 token that's got its basic transfer functionality. I'm able to say send you 10 dies in ERC20 token. When I do transfer, it's basically reducing my balance by 10 and increasing your balance by 10. With super tokens, we have additional logic beyond that basic transfer, and that is bestowed to it by the Superfluid protocol. And that additional logic is housed within super agreements. These are basically read-only smart contracts with that kind of that provide that sort of logic behind things like money streaming, right? So we have a super agreement called this constant flow agreement, which allows you to do money streaming, holds the logic for that. And so that kind of logic for additional balance and movement functionality is defined in super agreements, and it's connected to super tokens using the Superfluid host, which is kind of like the gel or the brain of the protocol that connects things together. So that is an overview of the Superfluid protocol in a nutshell. What you really want to understand is that it really just boils down to an extension of the ERC20 standard that has more balance movement functionality to it. So yeah, to double click into into super tokens. They're ERC20 compatible, right? So they do everything that ERC20 can, plus this additional Superfluid stuff. They're plugged into the Superfluid protocol. And because they're ERC20 compatible, they're usable anywhere in Web3, right? So you can imagine you could make like a sushi swap pool for them. You could do all that basic transfer stuff. You could stake them in Aave if there's a market for that. And so because they have that original compatibility, they're usable anywhere in the original Web3 kind of scene. And so super tokens come in two primary flavors. They come as wrappers and they come as pure. So wrappers, this refers to super tokens that can be wrapped. Super tokens that are wrappers for original ERC20 tokens. So for instance, DAI-X, that is a super token wrapper for the DAI token. And so you can't stream plain DAI. You have to wrap it into DAI-X, and now you can stream it. And when I'm streaming someone DAI-X at any time, they can take the DAI-X that they're receiving and unwrap it into original DAI and have the underlying token. These wrappers are totally permissionless, so you can make a wrapper for any ERC20 token out there, totally permissionless. We're not kind of like fixing these. So for instance, I had a Sunny token, an ERC20 token that I made for fun, and I just casually made a Sunny X wrapper super token. So now I can wrap my Sunny ERC20 token. It's got totally no value or significance, but I can now wrap it and stream it to people if I wanted to. So just to illustrate that. And then pure super tokens exist purely as super tokens. They're 100% streamable from the get-go. There's no underlying aspect to them. They're born and they're born as super tokens and work like them from the get-go. So yeah, that's super tokens. And I want to point out that the developer experience of using super tokens is very similar to ERC20s, right? So like how you would call a transfer on an ERC20 token, you'd specify a receiver and you'd specify an amount. With super tokens, creating a stream is very parallel to that, right? You specify a receiver and you specify per second flow rate. And just like that, you're able to create a flow in Solidity between a sender account and a receiver account. Just to double click into super agreements. Super agreements, like I said, they're the kind of smart contracts that are part of the Superfluid protocol that provide the sort of map and read-only logic to this additional balance movement functionality, such as money streams. I want to point out that there are two kinds of super agreements that we have out there at the moment. Well, two super agreements that we have out there in the moment. The first is a constant flow agreement, which allows you to do money streaming. So flow rate multiplied by time elapsed. And then there's instant distribution agreements, which allows you to do one-to-many distributions on the basis of proportions. This is outside of the scope of today's workshop. So just want to point that out, that it's out there, but not get into it. And so these super agreements are built into the token balance. And so you're able to basically layer on that sort of basic ERC20 balance movement functionality, as well as the sort of effects of these super agreements. So I want to kind of elaborate on how it's built into the token balance with this next slide. So I know this looks like a lot, and we're going to get through this, but I want to actually just go with an analogy here. So when I try to explain the real-time balance, I'd like to use this analogy of driving, right? So let's say I'm trying to go from Philadelphia to New York, and it's 100 miles. Highly encourage you to listen closely for this explanation, because it's gonna make a lot of sense if you're able to stay with me here. So let's say I'm trying to drive from Philadelphia to New York, and it's 100 miles. But let's say I've already gone 25 miles, right? Let's say I start driving at that 25-mile mark at a speed of 2 miles per minute, right? That's 120 miles per hour. I know it's not realistic, but bear with me for the sake of this example. So we're at initially 25 miles, and we're going at a speed of 2 miles per minute. And let's say 10 minutes elapse, right? Looks like I got some feedback, but we're all good. So 25 plus...
Sorry about that. I just added a little bit of background music I forgot to add. I completely apologize. Should have warned you. Go ahead.
You're all good. Cool. Yeah, so we're initially at 25 miles, and now we're starting to go at 2 miles per minute, and then we drive for 10 minutes, right? So the distance that we drove is 2 times 10. So 20 miles we've driven from that 25-mile mark plus the original 25, right? So we've driven 45 miles in total. So how does it apply to real-time balance? Well, let's say I'm receiving a money stream and my original DAI-X balance is 25. And Cody starts streaming me DAI at a rate of 2 DAI per minute, right? And let's say 10 minutes elapse. That means the real-time balance will be 2 times 10 in my favor, so plus 20. And then my static balance, I'm kind of referring to this graphic down here. My static balance will be the original 25. And so my total balance will be my static balance plus my real-time balance, which will come down to 45. Let's say another minute elapse. It'll become 46. It'll become 47, another minute, 49, and etc. And it'll carry forward like that. And so this sort of math is actually contained within the balance of function of the super token. So we're used to that balance of function returning the balance of your tokens, right? It's just like that with the ERC20 standard if you build with it. And so all balance of is doing is it's returning the result of that addition, right? That real-time math. And as a result, you're able to see your balance change in real time. With every second that passes, all balance of is doing when you call it is it's just running that calculation. How much time has elapsed since the stream was started, plus the original balance, and here's the result. And because blockchain's internal clock, like block.timestamp, increments on a per second basis with no need to update or submit transactions to update that number, we're able to get this sort of read-based increase in balance on a per second basis without having to submit transactions every second. We're not spending all this gas. We're just reading the result of this time elapsed multiplied by flow rate formula. So that is the idea, that's the concept of the real-time balance. And it's kind of like why streams are gasless beyond that first start stream transaction. So yeah, that's the real-time balance. And so the last kind of Superfluid concept I want to hit on before we get into the kind of building and stuff is super apps. Superfluid provides super apps. These are smart contracts that can react to streams. So basically, super apps have these special callback functions that when you start streams to them, they engage the appropriate one. So I could define a after agreement created callback, and when I start a stream to this super app, this special smart contract, that after agreement created callback will run, and you as a developer can program whatever kind of logic you want to that callback. So let's say that after agreement created callback has logic to mint me an NFT. If I start a stream to it, when I start a stream to that super app, that log in and I'll be minted an NFT. And so these super apps are kind of registered with a Superfluid host such that when you start streams to the super app, it'll be able to identify and trigger that callback logic. So you'll see this when we kind of dive in a little bit. But yeah, to point out 2 developer resources we have the SDK core, which is kind of like your JavaScript go-to for interacting with Superfluid. It makes it really simple to use your protocol. And as you can see, it's token-centric. So you're able to call like supertoken.createFlow, and that's a good time. And we also have the SuperToken V1 library, which you'll see in action as we review the smart contract today. It's just like the ERC20 dot transfer. You got dot create flow, update, delete, and kind of more supplementary functions, and it makes it really, really simple and a good time when using Superfluid in your smart contracts. All right, so it's time to build. I'm so hyped for this. It's going to take a sip to wash down my throat, and then we'll get into it. All right, so now it's time for what we all came for. Let's get into the Solidity. So I'm going to crack open my code editor. If you guys want to follow along, I believe Cody has pasted the link to the repository for this in the chat, so you guys can hop on there, perhaps even clone it locally and do some hacking of your own as I kind of review this smart contract. But yeah, let's get into it. So First and foremost, you'll see that the Flower smart contract is an ERC 721, so it's an NFT, and it's a super app. It inherits a super app base. You'll see that we're using the super token library for where we use super tokens. You'll see that each Flower NFT has a profile which contains the latest timestamp where a flow for the specific flower has been modified, right? So you're watering the flower. What was the latest timestamp where your stream has been modified to the flower? You have the current flow rate. So what's the current flow rate at which the flower is being watered? And then the amount of water that's been streamed to the flower since the last modification of the stream. So you may be asking, like, why does this latest modification matter? What's the point of this stream so far? And basically the point is to help us track how much water has been streamed for this Flower NFT. And you notice I'm saying water. That's because we're actually going to be watering this with a wrapper super token called WATERx, not DieX or anything. This WATERx super token, which kind of makes sense because we're watering a flower. So yeah, that's just a little side note there. But basically, we want to be able to keep track of how much has been streamed for a specific flower so that we understand, what the flower should look like as an NFT. And then we have these flower profiles. So, for each flower NFT token ID, what flower profile information does it have? It's up to that struct there. And then a mapping of accounts to their flower token IDs. So to note is that we're only allowing accounts, we're only allowing addresses to have one flower NFT at a time. It makes life easier for us for the sake of this smart contract accounting. And then we also have these stage metadata. So this is where we get into that evolving element of this NFT, right? So basically at the first stage is plant 1, second stage is plant 2, third stage is plant 3. And so as we continue streaming to this NFT, the NFT will graduate in terms of the metadata it returns. So before you start watering it, or before the watering kind of continues to higher stages, it'll initially show this metadata, right? And what this looks like is, if I can just pull up IPFS, this URL, you'll see that it has this JSON file that provides this metadata, which is the kind of standard that OpenSea is expecting, right? It also provides an image, which is what the NFT will look like on OpenSea, right? So if I go here, duplicate, break down its URL, you'll see that the flower at the first stage looks like this. At the second stage, it's going to look like this, so it's kind of budding. And this third stage is going to look like this, right? And so to kind of dive into that mechanic a bit more, actually, let me see if there's anything else I want to point out here. Yeah, I also want to point out the stage amounts, right? So you're able to designate in the constructor by passing in the stage amounts and saying it in the constructor how much tokens must accumulate for each stage to grow to the next, right? So let's say I make stage amount 0, 1,000, stage amount 2, 1,000. That means to get from plant 1, I have to plant 2, I have to stream 1,000 water tokens into the contract. 1,000 water tokens must have accumulated for plant 1, for the plant 1 metadata to no longer show, and now the plant 2 metadata to show. Let's say the second stage is 1,000. So it's stage 1 is 1,000, stage 2 is 1,000. That means if I stream 2,000, if I stream more than 2,000 WATERx tokens to the contract, plant 3 metadata will start to show, right? And that will look like this fully fledged flower. And so to visualize it a bit more, because it's important that you guys kind of understand that dynamic. You can imagine the flower NFT contract sort of like a cup with 2 tiers on it. And so before you hit kind of 1000 WATERx, you'll show this 2-leaf sort of image that and by the way, I know these aren't the prettiest things. I just went into Microsoft Paint and just went to work and made them happen. So bear with me. I know they're not the prettiest things, but they'll make do. And yeah, let's say you stream past 1000, then metadata 1 will show, metadata 2 will show once you stream past 2000. And yeah, to further visualize this, yeah, just gonna take another sip. Let's say you've streamed 1,200 WATERx so far to the contract, and the token URI function down here is able to identify that by calling this function inside it. It'll, based off of that, return stage metadatas of the appropriate tier, right? So if you stream 1,200, you're under 2,000, over 1,000, you should be returning metadata 1, and it will give you that corresponding image. So back to the code. We also designate the accepted token. So we only want to be, working with WATERx. We don't want the smart contract to be reacting to a stream of any other token. And we've got our token ID counter there. One thing you'll see here is we're registering the super app. So remember how I said that super apps need to be registered with the Superfluid host such that callbacks can be engaged. Well, that's what you're doing here. You're specifying, hey, host, let's register this as a super app so that streams are started to it. To try to trigger the callbacks. Superfluid provides before callbacks and after callbacks. Just don't worry too much about that. But basically, all this is doing is it's saying, hey, we don't want the host to look for before callbacks, just after callbacks. And then this is just an app level final thing. It's not that important, but it's boilerplate, so it's included every time. So yeah, in terms of modifiers, we have only host. So we want callbacks only to be engaged by the host. So that's kind of gate kept there. We don't want anyone to be able to go in and trigger that kind of those functions which are expected to only be in reaction to streams. So we gate them with this only host modifier. And then we have only expected. So we only want to react to WATERx, and we only want to react to the constant flow agreement super agreement, right? So we don't want to react to the IDA or the instant distribution agreement because there can be some messy stuff that happens there. So we're kind of protecting ourselves with this modifier such that we're only reacting to streams. Okay. So now we get into the callbacks, right? I'm not going to go super in-depth here. I'm actually going to hop over to some other logic, but let's just break this down at a high level. I know that these functions look verbose. You have the after agreement created, you got after agreement updated and after agreement terminated, and that really is what it sounds like, right? So if you're streaming to this contract and you start a stream or you create a stream, then this code is all going to run. If you update a stream, then this code runs. If you terminate a stream or you end a stream to the contract, to this Flower NFT contract, then this code runs. And so all that's happening in this code, we were able to customize it and write whatever we wanted into it. And so what I wrote in is that you want to get the sender of the stream. So you pull that out of this agreement data parameter right there. And you basically mint a flower to the person that starts a stream. So there's no mint function here, actually. You mint a flower literally just by sending a Superfluid stream to this Flower smart contract, which is pretty cool, I think. And so if you don't already have a flower, then you get minted. So that's the deal there. And then there's this flow update function here, which is helping us keep track of how much is streamed to the flower. And we'll get into that in a little bit. But basically, you'll see that the agreement, after agreement updated, this triggers after you update a stream to the contract. An update means like you change the flow rate. So let's say I'm streaming like 1 water per second, and I update that to like 2 water per second, then this code will run. And all this is doing is it's updating, it's running that flower update function. And same with after agreement terminated. Let's take another sip. So yeah, now it's time to talk about Flower update. I'm gonna hop back to the slides for a second, see if there's anything I want to touch on here. Yeah, so the super app elements you saw there, they're going to help us keep track of how much was streamed into the Flower contract. And so, like I said, these callbacks are meant to react to the creation, the update, and deleting of streams to the super app or the Flower contract. And so I want to kind of point out how we're going to keep track of how much has been streamed for each Flower, right? Because you're going to have multiple people stream to this contract. You don't want to, you want to make sure that you're accounting for how much was streamed to each Flower, such that each Flower is showing the appropriate sort of, the appropriate image. So let's actually visualize this before we get really deep into it. I want to point out the functions first. So we have this Flower update function, which is simply settling the latest information on the Flower. So like I said, this is running in every callback. It's just a generic Flower update call. And this is updating the Flower profile. So this is that struct up here that I talked about. We got this mapping of token IDs to Flower profiles and their corresponding information. This is what's being updated. We're updating the Flower profile. So we're just getting how much has been streamed so far with the stream so far function, and we're settling that in the stream so far latest mod, because the flow is just modified. That's when Flower update is called. When a flow is modified or it's created, updated, or deleted, those being the 3 modification cases. And so you're taking how much has been streamed so far and you're settling it to that stream so far at latest mod. We'll talk about this function because it's important. But I want to just give you guys an overview really quick of the Flower update function before we go any further. You're getting the current flow rate, the new flow rate. So let's say I minted a Flower for the first time by streaming to it. Originally, this flow rate would be 0, but now it would be whatever the flow rate is at the moment. So it could be like one water per second. And this would simply pull that, just getting the flow rate and settling that and setting that in the Flower profile struct or mapping. And then you're getting the latest timestamp where the flow is modified. So let's say back to the case where I started a stream to the Flower contract for the first time. This will get the current block.timestamp and set that in the Flower profile. So let's sort of visualize what stream so far is doing and how we're able to track how much has been streamed so far for a particular Flower. It's really all housed within this piece of logic here, within this function. And so before we kind of like tackle this math, and that's all it really is. It's just math. It's just the linear equation. But to illustrate that, I want to take you guys to this diagram here. I see we have it's myself. I don't know why there are 2 of me, but yeah, basically this is an illustration as to how we're able to track how much has been streamed for a specific Flower. All right, so let's say in scenario 1, you start a 1 water per second stream to the Flower contract, and you are minted a Flower NFT with token ID 1. So your stream so far at latest mod would be 0. Remember, stream so far at latest mod is this variable in the Flower profile. And so that would be 0 because you just started streaming. There's no water that's accumulated so far for your Flower. And you mint this and you get this Flower NFT in exchange. Now let's say 100 seconds pass, right? 100 seconds have elapsed. Stream so far at latest mod is still 0 because the latest modification was when you just started the stream and no water had accumulated because you just started the stream, right? That was how much was streamed so far at the latest modification. So that's 0. However, the amount that you've streamed so far is 100, right? When you call stream so far, it'll return 100. Why is that? Let's get into the code. It is because stream so far is simply taking this little, it's capturing this variable, stream since the latest mod. So how much has been streamed since that flow was created. And all that is just rate times time elapsed, right? So it's just saying, okay, this is a flow rate. There's some changing the data type here. That's all that is. But this is the current flow rate at which you are streaming to the flower. This is how much time has elapsed since you started that stream. You modified it. And so that's current block.timestamp since that minus that latest flow mod. So that's time elapsed. And you're multiplying those two and you're getting how much has been streamed since latest mod. So it's flow rate multiplied by time elapsed, and you're getting that how much has been streamed since latest mod. So in the case of this example, that is 1 water per second times 100 seconds that have passed. So that returns 100. Now that's not exact. It's not just returning stream since latest mod. It's adding that to the stream so far latest mod, which is 0 because nothing was streamed when you just started your stream. You just started it. So it's 0 plus 100. Stream so far would return 100. Now let's carry on a little bit, get a little bit deeper into the logic here. Taking another sip because my throat is dry. Yeah, basically, let's say on the 100th second, exactly when the 100th second strikes, you modify, you increase your stream to 2 water per second. You've increased it to 2 water per second. It's no longer 1 water per second. It's 2 water per second. That's your flow rate. What happens is stream so far latest mod gets settled to 100, right? Because when you call flower update, you are capturing that stream so far value, and that was 100 at the 100th second, like we talked about. And so now stream so far latest mod equals 100, right? Now this section of this function, this variable returns 100 now, right? Sorry if I go back here. And if you call stream so far, it will still return 100 because this portion is 0 now, right? This got zeroed out because the flow rate, while it's now 2 per second, the block.timestamp minus latest flow mod is 0 because block.timestamp equals latest flow mod, right? Because you just updated it, right? Latest flow mod just took on the value of block.timestamp, right? They're equal. And so a number minus a number, that same number is 0. Stream since latest mod is 0. So this is just going to return 100. And let's say time elapses again, right? 13 seconds pass, just 13 seconds. Then stream so far will return 126, which is what we expect because 13 seconds, this will return 13. The flow rate is 2. Stream since latest mod equals 13 times 2, that's 26. And then you're returning 100 plus 26, and you get 126 as your stream so far output. And so this is how the Flower contract keeps track of how much to stream to it, right? So it's 100, that is stream so far latest mod, plus this real-time component of time elapsed multiplied by current flow rate. And that is, sorry, I'm just gonna change that to stream so far. It's not get stream so far. It's just doing that addition, and it's returning that number. And that's how the Flower NFT knows how much was streamed to it and is able to return the appropriate metadata. So yeah, that was stream so far. You see now why we need this kind of super app reactivity so that we can sort of do those updates when streams are created, updated, and deleted, and update the appropriate information with this Flower update function and encapsulate how much was streamed so far to it. Great. Couple more things I want to point out. Let's say, so this is where the magic happens. This is where the Flower contract is actually returning the amount that's been streamed. Sorry, this is where the Flower contract is actually returning the appropriate metadata. So it's pulling from stage metadatas up here, right? And this is what we set in the kind of state information here, these levels of metadata. And all this is doing, I'm not going to get super into the logic, but it's just iterating through each stage and seeing, okay, is the amount that's been streamed so far, is that actually within a certain range? And if that falls within the stage's amount, then we're returning the appropriate stage metadata, right? So let's say, you know, this really just goes back to that diagram we did here. It's simply iterating up each stage. Is it within under 1,000? No. Is it under 2,000 but greater than 1,000? Yes. Okay. Then token URI should return stage metadatas of 1, which is a second metadata image. So that's really all there is to it. And then if it's past all the levels and it's just going on to oblivion, then it's going to return the final level, which is that full-fledged flower. All right, so that's all token URI kind of does. It's just reading the result of stream so far and returning the appropriate NFT stage in terms of NFT image for how much was streamed to the flower. I also want to point out that we got this before token transfer hook. So we want to allow people to, I don't know, transfer their flowers around, but we also want to make sure that they're not destroying our internal contract accounting while they're doing that. So basically all this is doing is it's making sure that, you know, you're not sending a flower to someone that already has a flower. Oh, and before I go any further, like for those of you who are unfamiliar, the before token transfer is from the ERC 721 interface, and basically it allows you to define for this NFT some logic that is to occur before you transfer the NFT. So anytime anyone wants to transfer this flower, this piece of logic will automatically kick in within before token transfer. So it's like a hook. It's like engaged when this transfer happens. So that's what it is. And that's actually available for all ERC 721s. It's part of the interface. It's just not commonly used. But basically, yeah, we're making sure that you can't transfer a flower to someone that already has one. If you transfer away your flower, then if you're already watering it, then your stream gets canceled. So you're not kind of like, I don't know, streaming, but you're not like actually watering anything. And then you're also doing a flower update because, you know, the flow action was taken. And then you're updating the ownership. So now you no longer own the NFT. This new person does, and that's updated. That's updated in the mapping there. Great. Awesome. So that is the entire flower contract. That's all there really is to it. This isn't that long, right? It's just, you know, nearly 300 lines of code, but we were able to create this really cool dynamic NFT experience, which is pretty fun. You're like watering an NFT. Where have you ever seen this being done? So let's get into a live demo of the flower NFT. Let's put this to practice. So I'm going to crack open my excuse those errors right there. But I'm going to deploy a NFT here. Right. So if I get to the deploy script, I just want to show you guys what I'm deploying before we really get into it. So we are basically calling the constructor. We're deploying it with this information. We want each stage to be 10 water, right? So 10 water per each stage. So, you know, for the first stage, if you haven't streamed more than 10 water, then you're going to show that, you know, 2 leaf image. If you go and you stream more than 10 but less than 20, you're going to show that second image. And then any more than 20, you're going to show that final flower image. And so, yeah, that's kind of the sort of settings here. We're making these like 10 tokens per stage. So let's deploy npx hard hat run scripts deploy flower.js. We're going to do this on Girly Network. Is there anything else I need to keep in mind? No, let's do it. So I'm gonna wait for that to run. In the meanwhile, I'm gonna prepare to verify the contract. So this is something I really like to do when I'm deploying contracts on testnets. I am usually verifying them. So if I want to kind of review the code on WATERx or wherever, I can conveniently access it. And as you can see, we've successfully deployed our Flower contract to this address. So I'm going to run this verification command. And I'm going to copy over this address. All right. And all this is doing is it's allowing us to specify what the arguments we put in, right? So these are the stage amounts. These are this is accepted tokens. This is the address of WATERx. This is already out there on Girly. And so we're just going to be using some Girly that I already have in the wallet that's being used for this demo. But we're going to go forward and verify this smart contract, this Flower smart contract that's out there. Yep, nothing to compile. I'm actually going to load this into this nice sort of tracking file I have here that tracks the address of each contract involved with this demo. So Flower address, this is a previously deployed one. I'm going to put in the new one. This is the address of water, that being the underlying water ERC20 token. And then this is the address of WATERx. This is what we're streaming to the contract to mint and grow our NFT. And so because this is exportable, you can now access these variables in any sort of script that I'm running, and you'll see that being put to use. But before that, you'll see that we successfully verified our contract. So if I click there, you can see here that our contract has been verified. If I get into flower.sol, you can see that we can view the contract, all the code that we wrote, all this good stuff right here on Girly Scan. By the way, guys, Girly is getting deprecated, so I encourage that you guys think about using Sepolia or the Polygon Mumbai testnets because Girly will go under very soon. But I'm sticking with it for the sake of this tutorial. And yeah, deploy Flower. We just deployed our Flower. Now it's time for the big thing, which is to stream to the Flower and actually mint our Flower and start to grow it as a result. So you can see here, we're employing in our Alchemy Girly URL. We are initializing the Superfluid framework. So that's that JavaScript SDK core that I talked about. We're getting our signer, and then we're creating a flow operation. This can be found in the docs, more information on how this kind of works. But all we're doing is we're starting a stream with WATERx. We're sending it from our account. We're sending it to the Flower smart contract, and we're sending it at a flow rate of 10 water per every 2 minutes, or 5 water per minute. And the reason it looks like this is because flows are always on a per second basis, right? So this is the amount of way that we're sending or we're streaming per second, right? And so if we spread that out to a kind of a minute by minute basis, it would come down to 5 WATERx per minute. And with this, we're just executing the flow, and if it all goes right, we'll see that we stream successfully. Now, there are a couple things I want to get ready before we actually start that stream so that we can kind of monitor the growth of the NFT, because as soon as I start that stream, right, the NFT is going to be minted to me, and it'll start accumulating water. And because we're streaming at a really fast rate, we're streaming like 10 water for every 2 minutes. I want to make sure that we have this stuff ready to see that water, to see that Flower NFT graduate from metadata to metadata. So let's first go to the Superfluid console. The Superfluid console is really cool. It basically is the Etherscan of Superfluid. It lets us see, for instance, this address that I was experimenting with before, like, you know, how much water is being streamed to it, when it was like streamed, and all this information, who is streaming to it. Well, let's go to this newly deployed Well, I can't go to it because I haven't even streamed to it yet, so it's not indexed. So yeah, I just want to have this tab ready. And then I also have this nifty little NFT viewer website called Nifty NFT Viewer that I can use to view different NFTs, right? So currently, we're going to the smart contract that we newly deployed for token ID 1. It's defaulting to showing you this current sort of first level of metadata. We'll see this graduate as we start our stream. So since we just deployed the contract and we're the first people to stream to it, we will be the first people to mint an NFT on it, and we'll get token ID 1. So I have this ready to go for when that happens. I'm going to copy that again, and we're going to start our stream. We're going to run the start streams, the stream water script, and we'll get right to it. While I wait for this to run, is there anything else I want to point out? Yeah, we're just starting to stream to the Flower contract. Nothing crazy there. So stream successfully created. Let's go to the console to see that stream happening. Boom, on Girly, you can see that water is being streamed from my test wallet into the contract at a really fast rate. If we go and we modify this on a per minute basis, you can see it on stream at a rate of 5 water per minute. If I go to my wallet, I can see that I have just created a flow, and that has bestowed me the flower with token ID 1. And obviously the NFT is returning this first level of metadata because remember when I deployed, I had each level of metadata be 10 water, right? So I haven't streamed more than 10 water, and so it's still showing that first stage. And that is this little sapling of two leaves. So we're going to wait for a little bit for the amount of water to accumulate past 10. And this is really cool, right? We're literally just streaming water in real time into the contract. I know this looks like it's like moving every millisecond. In reality, it's happening just every second. This is just UI sugar to make it look really cool. And it sure does look really cool. But yeah, that's what's going on here. WATERx is accumulating, and once it hits past 10, we'll be able to refresh this, and we'll see that the Flower NFT has grown from this to that budding image, right? It grows to look like this second level of growth. So sure enough, we're almost there. Boom, so we passed 10. Let's go to the Flower contract really quick. So we go to the contract, we should be returning plant2.json. And sure enough, we see plant2.json. Plan 1 has passed, so now we're on plan 2. And if I go to Nifty Viewer, I hit search again. Boom, it grew. It grew. We didn't submit any transaction. We just streamed water to the contract, and the NFT just grew right before your eyes. Isn't that crazy? So we have successfully watered the flower, and it has grown to another level. If we wait a little bit longer, it'll grow to plant3.json, and we will be able to see it develop into a full flower, right? So I'm just going to do myself a favor and update this in the README for you guys. I'll push these changes. But yeah, I just want to give you guys a quick start here for those guys who are looking to just experience the growth of the NFT. I've got this README that breaks down the way that you can try it out live on your early testnet. So I'm just putting in this new deployment there for you guys to try out. Yeah, we're almost at 20. Once we're past 20 water streams contract, 20 water accumulated in the contract. We'll be able to update or refresh this, and we'll see the full flower, right? That being this full flower right here. Yeah, so that is what's happening. Just want to drive home, like, I did not submit a transaction for that metadata to change from that 2-leaf looking image to this, budding image. It was simply just a result of reading how much was accumulated in the contract and returning the appropriate results. There was no kind of like need to submit transaction, pay gas, etc. It was done gaslessly. And so now we passed 21 water streams to the contract. We go here, watch closely. We're at plan2.json. Watch this magic happen. Boom, plan3.json, because we have streamed more than 20 and we're on that final stage. And if we refresh, boom, we have reached the final stage of growth for the Flower NFT. It is now fully blossomed, and it's reached its final stage. So mission accomplished. Mission accomplished. So guys, that closes off my kind of demo part of this workshop. That is how the Flower NFT works. That is the rundown there. I hope you guys enjoyed that. You learned some more solidity, and you've kind of seen what's possible with Superfluid streams and just how composable they are and how flexible they are. I was able to integrate that kind of money stream into a really cute NFT use case where I was able to water an NFT, and that was a great time. So yeah, Superfluid is useful for a lot of things, right? You can stream salaries with it. You can make subscriptions. You can make a lot of really cool programmable experiences. And it's really just a matter of, extending the ERC20 to include this ability to stream, right? It's a very simple developer experience, as you saw. So that is a nice kind of integration use case there. I want to point you guys in the audience who are builders to this resource that we provide called the Superfluid Wave Pool, in case you guys are looking to get started building with Superfluid technology and have a nice kind of incentive to do so. So all the Superfluid Wave Pool is Superfluid's continuous, never-ending, 24/7, 365 hackathon, right? The Wave Pool is always open for submissions, and it resets every single month. So with each month, you have a new wave, and with each wave, you have a new set of prizes. And these are substantial prizes, right? So for the current wave for March, we have over $8,000 worth of prizes. We have a co-sponsor bounty with Chainlink. So these wave pools are a great way to get in there, build with Superfluid, come up with different projects, and have a good time building with their technology, really experience the kind of cool things that you can build with Superfluid, like what you just saw here with Flower NFT, and get rewarded for it. So we're really looking forward for people to, tackle cool stuff with Superfluid, and our DevRel team is here to help you guys with ideas every step of the way. You can find all the information you need at superfluid.finance/wavepool. And yeah, I hope you guys dive in and start surfing the waves with the Superfluid Wave Pool. It's really a great time and a great program to put on. And yeah, that's out there for you guys. And lastly, I just want to say, get in touch. I love everything Web3. I love everything finance and DeFi. Happy to connect over this. If there are things that you didn't understand, I'd love to kind of smooth out your kind of understanding here. You can find me on Twitter or Telegram at SunnyJacer. Let's get in touch and let's connect if you would like to. So that's my contact. And with that, I want to say thank you for a great workshop on behalf of Alchemy and Superfluid. This was a great time, and we'd love to hear if there are any questions and, kind of close it off here. Wrap it up. I'll stop my share.
Oh, just realized I was muted. Sorry about that. Typical live streaming error, right? Yeah, that was fantastic. Thank you so much for doing that. Really cool to kind of see it in action of the NFT kind of growing and thinking about creating smart contracts in that way. Normally we just had something that we were trying to create a certificate NFT for Alchemy University, and we were thinking like, how do we do that dynamically? And we wound up doing something very yeah, we wound up doing a static NFT. But this is like a cool, interesting way to try to attack that problem.
Right.
Yeah, and I think this opens up a lot of creative ideas for people, I believe, just seeing this.
Yeah, I feel like there's a lot of kind of design space afforded to you in Web3 by just being able to like read information on chain and return the appropriate stuff and sort of do math behind the scenes. And you
Right.
kind of saw that at play here. Not everything has to be like submitting transactions constantly when you're trying to update things. You can just read information. So
Right. I mean, especially towards this new age of Web3 that we're hitting, right? Where we're focusing more on how do we make the UX better? How do we make people that aren't familiar with Web3 over the past 3-4 years? How do we onboard them? So yeah, this is fantastic. I really enjoyed this. If anyone wants to work on this in the future, all the repos are in the YouTube, and definitely check out Sunny and Superfluid on the links that I posted in the chat. Cool. I don't think that I saw any outstanding questions. Just a bunch of thanks and people excited about seeing this project. So yeah, thank you again, Sunny. And is there any parting words that you want to say here?
Yeah, I just want to say again, thank you so much for letting me, have this platform to contribute to the Alchemy University. Just an awesome free resource for Web3 developers. I myself tried out that JavaScript little bootcamp, and
Fantastic.
It was a good time. So yeah, I hope that you guys learned a thing or two today. It's a nice kind of like a more advanced kind of Solidity example here. And yeah, if you want to again maybe pick it up and build some cool stuff with it, the repo's there for you. And my contact is at SunnyJacer if you'd like to, talk shop. So thanks.
Awesome. Last thing I want to say to you is I did not know about Superfluid Wavepool. That is really cool. I think that is something I'm going to point all graduates of Alchemy University to. I'm always looking for, what hackathons are available, what's kind of going on. Students are looking for what can they do next. I think this is perfect and something that a lot of companies should replicate. Just there's so many hackathons going on. People don't know whether to spend their time here or there. For something that's continuous and that people can really just devote some time into if they're really interested in the protocol, I think is super smart. And I'm definitely going to promote this. So thank you for sharing that as well.
I really appreciate that. Yeah, you definitely hit the nail on the head. It's really just a way for you guys, for people that are kind of doing the development to pick up and sort of like, I guess, add to their kind of Web3 resume, or their portfolio by building something with Superfluid, which is a bit more of like a step up, right?
Mm-hmm.
So yeah, it's out there and it's always running, so it's a good time.
That's fantastic. And how do people submit projects? Is that like through GitHub? I see the link here. Is it just kind of a quick submitting process on here, or could you talk a little bit about that?
Yeah, for sure. So it's superfluid.finance/Wavepool. It takes you to a page in our documentation. Eventually, we'll have a landing page for it, but for now, the documentation will suffice. But yeah, it's just an Airtable form. It's totally open. There's no registration needed. We wanted to remove as much barriers as possible to getting involved with it. And literally, you're just creating like a little devfolio page for your project, and then you are submitting that devfolio link to the Airtable form. And then at the end of the month, me and the DevRel team, we judge the projects and we assess prizes, and we're pretty generous with it. So
fantastic. I love to hear that. And I know developers will as well. And it gives me a ton of ideas for project submissions that we just did for final projects, and how we can maybe hook into this automatically and give people options. So this is super exciting for me, and for students. So thanks again, Sunny. Yeah, I think we'll close out here. Again, feel free to contact Sunny on his Twitter, on Superfluid, and jump into their Discord and chat with them and build on Superfluid. Thank you so much. And thank you everyone for joining us today. Have a great day. Have a great weekend. Take care.
Have a good weekend, guys.